Okay, lesson 17.4, day 1 is on similarity in right triangles. And so we are going to take a look at the activity that we were supposed to do if we are actually working as a class, similar triangles. So if we take a look at this set of triangles, if we take this triangle and we cut through the triangle like this, we will have created 3 triangles. The original one, and we will call that triangle 1. And then we have the top one and the bottom one. So there will be 3 triangles together. And if we were to label these triangles with A, B, C, the coordinate, then the divided triangles will have, let's call this D over here. We can redraw the 2 triangles. Let me redraw triangle 2 and triangle 3. So triangle 2, we will have A, D, B. And triangle 3, we will have B, D, C. So if I were to write a similarity statement for the 3 triangles, that would be triangle A, B, C, similar to triangle A, D, B, similar to triangle B, D, C. That should be D. And so similarity drawing the figure, lining up the triangle. Remember our strategy to redraw the figure with this similar triangles is very important. So that is how you should line up the triangles whenever you see a triangle that is divided into proportional parts. So what we just did right here by drawing this segment to divide the original triangle into 2 triangles, we call that ratio the geometric mean between that side and that side of the triangle. So we have this again, this middle side that we use to cut the triangle into 2 parts is a proportion between those 2 sides right there. So the way that we set it up, let's use example here. We will have this side, we will call that, we can call it X, and we can call that Y, and then we can call that Z. So the way that we set it up is X over Y equals Y over Z. Notice this Y is repeated, so it's the mean between the side that is divided. So X to Y equals X to Y equals Y to Z. So if you can think of it that way. Okay, and we can find the geometric mean for a pair of numbers using the same ratio that we just did. So let's take a look between 4 and 25. So we're going to call it 4 to X is equal to X over 25. So the way we set up is we let X be the geometric mean between 4 and 25. So now we're going to cross multiply. X times X gives us X squared. 4 times 25 is 100. To solve this equation, I take the square root of both sides. So I have X equals 10. So we say that 10 is the geometric mean between 4 and 25. Let's try another one. Between 9 and 20, notice that I can set it up again as 9 over X equals X over 20. So that X is the mean. Cross multiplying, we have X squared is equal to 180. And to simplify 180, we can use the simplifying method for the square root. That's 9 times 20. And then we also have 20 is 4 and 5. So we can rewrite 180. The square root of 180 is the square root of 9 times the square root of 4 times the square root of 5. And we know the square root of 9 is 3. And then square root of 4 is 2. And then we have radical 5. Multiplying the 2 numbers together, we have 6 radical 5. So that is the complete simplifying for square root of 180. So coming back to the problem, to take square root of x, that's how we solve it, square root of x squared, we will have x equals 6 radical 5, and that is what radical 180 simplifies to. Let's try another one. 6 and 24. So we have 6 over x is equal to x over 24. Cross multiplying, I have x squared equals 144. And taking the square root of both sides, I have x equals 12. So 12 is the geometric mean between 6 and 24. You need to pause the video at this point and try this next problem before you look at the answer. So go ahead and solve it. Hopefully you just had a chance to try the problem and set up 5 over x equals x over 12. Cross multiplying, I have x squared equals 5 times 12, which is 60. Again, to simplify 60, I'm going to do it on the side here. That would be 4 times 15. And so taking the square root of both sides, I have x is equal to the square root of 4 times the square root of 15. And I know that square root of 4 is 2, so that simplifies to 2 radical 15. So that is the geometric mean between 5 and 12. Okay, let's take a look at this example right here. So again, the geometric ratio, let's just summarize this using this figure. X represents the length of this segment, which means it is a geometric mean between these two broken sides right here. So the geometric mean is going to be b over x equals x over a, or a to x equals x over b. So you'll notice that x is repeated, and then a and b are the extreme ends. So let's apply this problem to the next example. This is a triad problem, so again, pause the video and try the problem before you actually do this. In this problem, we're going to be redrawing the figure so we can rewrite the triangles. As in, there are 3, just like we did earlier, that there will be 3 triangles. This is the original one, so we will label it X, W, Y, and then the 2 and 3. So this will be triangle 1, the original, and then we're going to draw 2 and 3. So triangle 2 is actually going to be W, Z, and Y, and triangle 3 is going to be X, Z, W. So you would have to look at it at a different angle to see that those are the lined up coordinates, and then we can rewrite this as triangle W, X, Y, the original, is similar to the second triangle, which is Z, W, Z, Y, and triangle Z, X, W. Actually, it should be X, Z, W. So that would be the similarity statement between those 3 triangles. And we're going to take a look at the triad problems here. So at this point, you also need to pause the video to try the problems. And so to find the geometric mean between 1/4 and 4, it is 1/4 over x equals x over 4. Cross multiplying, I have x squared equals 1. And taking the square root, x is equal to 1. So 1 is the geometric mean. For the next one is 3 over x equals x over 75. Cross multiplying, I have x squared equals 225. And taking the square root of both sides, I have x equals 15. So we need to take square root. And for the next problem, number 6, 4 over x equals x over 18. Cross multiplying, I have x squared equals 72. And taking the square roots of both sides. X is equal to 72 is going to be 36 times 2. So it is going to be square root of 36, which is 6 radical 2. Next one, 1/2 over x equals x over 9. And we have x squared equals half of 9, which is 4.5. And you can just take the square root of both sides, which is going to be approximately 2.12. And number 8, 10 over x equals x over 14. So x squared equals 140. And so x is equal to the square root of 140, which is 2 radical 35, because you can only multiply 140 by 4 times 35. And the last one is going to be 4 over x equals x over 12.25. Cross multiplying, I have x squared equals 49. Therefore, taking the square root of both sides, I have x equals 7. So those are the answers for all 6 of these problems. Hopefully you have tried it and got the answers correct. And now you're going to go ahead and pick up the worksheet from the sub on worksheet 17.4a, and you're only doing 1 through 8. So there are only 8 problems on geometric mean. So make sure you do the side that says similar triangles. And that's the end of day 1.